So in this video, what we want to do is calculate the slope or the rate of change at a specific point on a curve. Okay, so let's say I want to calculate the rate of change at this point here on this curve. And it doesn't actually even matter what the function is or what the equation is. We're just talking about a general concept. So let's say, just for the sake of easiness, right, I'm going to call this point x, and the associated y value would therefore be f of x. Okay, and I want to calculate the slope at that exact point. So what we know from Algebra 1 is when you calculate slope, you need a line, right? And so what I'm going to do is I'm going to draw what's called a tangent line. And that tangent line is going to approximate my slope. So this is my tangent line. Okay, now the problem is, to calculate slope, I need 2 points, right? And so far, how many points do I have? Just one. Okay, so that's not going to work. I need 2 points. Currently, this point here is x comma f of x, right? So how am I going to get another point? You know, one of the thoughts is, okay, well, what if I took a point on the tangent line? Could I figure out this point, right? Well, the problem is, like, how am I supposed to know what this point is? Like, there's no numbers associated with it. I don't even necessarily know, even if I knew the function, like even if I had an equation for this function, how would I find like this random point that's not on the function? I would never be able to find like a specific x or y value, right? So although I would want to look on the tangent line to find a second point, I don't even know mathematically how I would know what those would be, right? Because this tangent line isn't actually on the curve. So what we're going to do in calculus is get a little creative. We're going to say, oh, we don't have a second point? Well, here's what we're going to do. We're going to make a second point. We're going to make the second point on the curve that we actually have. And the second point is going to be completely off. It's not going to be, perfect, but here's our second point. And our second point is going to be located h units away from the first point. So this point here is going to be x plus h, because this distance here is h units. Okay, so I'm gonna just put a second point on the function. Now, just so we understand, the coordinates of this point, right, if this is the input of x plus h, the output is f of x plus h. And the second point here has the coordinates x plus h, comma, f of x plus h. Hopefully you can see all of that. I think so. Okay, now, what I'm going to do is connect these 2 points, remember, because I just know my formula from Algebra 1. And this line that I've drawn, you may remember from geometry, because this line intersects the curve in 2 points, this is called a secant line. And I'm going to calculate the slope of the secant line. And just as an FYI, the slope of the secant line is actually also called a difference quotient. That's vocabulary you need to know, difference quotient. Now, I know what you're thinking. You're thinking, Mrs. Bailey, this is a horrible idea. If you're going to calculate the slope of the secant line, and I'm just going to make up a number. Let's say the slope of the secant line is like 3, right? That's a horrible, horrible, horrible approximation of the slope at this tangent line, right? The slope of this tangent line looks a lot less steep. It looks like, I don't know, maybe it's 1, right? If you're going to tell me that you're going to instead calculate the slope of the secant line, that's going to be a horrible idea. It's going to be totally off. It's going to be such a big error. You're not even going to be close. Like, what are you thinking? Right? And so I get where you're coming from. It is going to be completely off. It's going to be wrong. It's not going to be correct. the slope of the secant line is not going to be a very good approximation of the slope of the tangent line. So what you're thinking is absolutely correct. This sounds like really not the best idea, but so far it's all we know how to do. So in the next video, I'm going to explain how I can improve upon my horrible initial calculation, right? The slope of the secant line is nothing like the slope of the tangent line. And I'm going to show you how I can get creative and actually make the slope calculation a lot more accurate. So stay tuned and I will explain that in the next video.